What's up, guys? Today's video is going to be on simplifying radicals. We'll be doing some more practice. And we're also talking about what we do when there's a negative sign under the radical, which means that it's a complex number. Remember that I is a symbol representing the square root of -1. Anytime there's a -1 under a radical, we can rewrite that as I. It's not a variable. It's just a symbol that represents something, like pi represents a number. I represents a number 2. Okay, so what we're going to do here is I've got the square root of -4. Okay, well, think about it this way. I can rewrite that as the square root of -4 is really just -1 times 4. Would you agree with that? -1 times 4 is -4. So this is the same thing, right? I just kind of split it apart. Well, another property of radicals would say that we could split this into two separate radicals if we wanted to. And I'm showing a lot more work here than I would normally do, but I want to help you understand why we do this. Okay, so this is all still equivalent. Well, the square root of -1 is simply I, right? So this is really just I. And the square root of 4 is really just 2. Okay, so what you have here is I times 2, or as we're going to say it, 2I. Now, I normally wouldn't write nearly that much out, but I want you to understand that whenever you see a negative sign, you can just immediately pull that out and put an I on the outside. And then whatever's left, you still need to simplify it just like we did in the last video. So here's one that looks like the last video, except I've got a negative sign under the radical. And I also put a negative sign out here just to add another layer of complexity, but it really doesn't make a big difference. You just keep whatever's on the outside negative. Okay, so the very first thing I want to do is I want to say, well, that's a negative sign on the inside, so I'm going to pull that out as an I. Okay. 18, I can split that up into 9 times 2, right? And so maybe I should go through here and split this up a little bit. So I want to go ahead and pull the I out. So I've got a negative I on the outside. Now, remember from the last video, we said 18, does it have any perfect square factors? And it does. 9 is a factor. So I can write that as 9 times 2. X squared is a perfect square. Y to the third is not a perfect square, but I could write that as y to the second times y. So I've factored everything out into its perfect square components. Okay, so the 9 can come out as a 3. The x squared can come out as an x. And the y squared can come out as a y. So everything I pulled out goes in the front. Everything left behind has to stay behind. Okay. Now I want to be deliberate about the order that I put these things in. You typically go number and then letter, and then you want to put I at the end. At least that's the way I like to do it. So I'm going to say negative 3x, y, I. And what's left behind is just a 2 and a y. So continuing on with simplifying complex numbers, we need to know how to simplify powers of I. Okay, so I'm going to write out a few powers of I here. We're going to start with I to the 0. We're going to look at I to the first, I to the second, and I to the third. And we're going to think about what we know about I to go through and simplify these. Well, I to the 0 power, that means, remember from our exponent rules, that anything to the 0 power is 1. It doesn't matter if it's I or anything else. Anything to the 0 power is just 1. I to the first power is just itself, so that's just I. Now you should remember this from last year, but I squared, that means the square root of -1 times the square root of -1. Let me go off to the side here. If I do the square root of -1 times the square root of -1, remember anytime you square a radical, you simply cancel out. You're squaring a square root, essentially. So this is just -1. You should remember that from working with I in previous math classes. But you definitely need to memorize that I squared is -1. You're going to use that a lot throughout this course. Okay, so continuing on, every time we go up another power of I, that means we're multiplying by another I, right? So we started with 1, and 1 times I is I. Then I times I is I squared, which is -1. And now you multiply it by another I. So what's negative 1 times I? That's going to be negative I. You need to memorize these four, okay? And if you notice that each of these reduces to either a 1 or an I, or a negative 1 or a negative I. But ignoring the sign, it's either a 1 or it's an I. And as it turns out, any power of I can be rewritten as one of these four. Any whole number power of I, you can rewrite as one of these four, okay? So for example, if I say I to the fourth, let's continue it for a second. Using the same reasoning we used earlier, if I say negative I times I, because every time we add another power, so we multiply it by another I, we're going to say negative I squared multiplied by another I. Well, that looks different, but it's not different because I squared actually is negative 1. So what you've got is negative, sorry, I wrote that backwards, negative 1, which is 1. Okay, so we're actually back up to here. If I were to go to I to the fifth, we're going to multiply by another I, which gives us plain I. Again, we're back to here. So every time you go down a step in this sort of list, where that's another power of I, which means you're multiplying by I again. And since it starts repeating here, that means it's going to keep repeating, okay? So you've got I to the 0, 1, 2, 3. I to the fourth would be equivalent to this. I to the fifth, 6th, 7th, 8th, 9th, 10th, 11th, and so on. You just keep going around in a loop, okay? That means I to the 0 is actually the same thing as I to the fourth, and I to the 8th, and I to the 12th, and you can just keep going, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It just keeps repeating. And you may notice that these are the multiples of 4. What about these numbers, the next row? It's I to the first. It's also going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 5 and 9. In other words, these are the multiples of 4 plus 1. These are all 1 more than a multiple of 4. These are all going to be 2 more than a multiple of 4, or 1 more than whatever these are. So it would be I to the second, I to the 6th, I to the 10th, and it would continue in that way. Notice that you're adding 4 each time. In that last row, I to the third, that'd be the same as I to the 6th, or I to the 11th, and so on. It also keeps repeating. Well, when there's a pattern like that, there should be some kind of shortcut here. Okay, like for example, if I ask you, I say, what's I to the 14th power? Well, you can sit here and count, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and say, oh, that's the same as I to the second, which is negative 1. So actually, I to the 14th is just negative 1. But we don't want to have to keep looping like that through here. We don't have to count. It's like using finger counting or adding or subtracting. I mean, you can do it, but you don't really want to, right? Especially if I ask you a bigger number, like if I say I to the 27th. Well, now we're starting to get to the point where I don't really want to count that out, okay? So we want to know a shortcut here. Do you see anything in common with these numbers versus these numbers versus these numbers versus these numbers? In other words, what does each row have in common with that row? These are all the multiples of 4. These are all the multiples of 4 plus 1. These are all the multiples of 4 plus 2. And these are all the multiples of 4 plus 3. In other words, if I divide any of these numbers by 4, I get a remainder of 0. And if I divide any of these numbers by 4, I get a remainder of 1. And on these numbers, I get a remainder of 2. And down here, I get a remainder of 3. In other words, the remainder you get when you divide by 4 is what it's equivalent to. It's that power of I. So 27, if I divide 27 by 4, well, the closest multiple of 4 to 27 would be 24, which means I have a remainder of 3. And I to the third is negative I. It's that easy. It's a lot faster than counting. If I say I to the 85th, well, what's the closest multiple of 4 to 85? Because 85 is not a multiple of 4 itself. maybe you don't know. Maybe you can't very quickly think. So what I tell people is, if you can't very quickly come up with a multiple of 4 that's close to it, then pick one that's kind of close to it, like 80. 80 is a multiple of 4, obviously, right? Well, if I count up from 80, I go 84. If I count by 4s, so you've got 80, then 84. Well, 84 is going to be the closest multiple of 4 then. That means there's a remainder of 1. So this is I to the first, which is I. So no matter what number I put here, you should be able to reduce that down to either a 1, a -1, an I, or a -I.